What's up, guys? It's time for part two of this Algebra 1 EOC review. It's been a long time coming, but here it is. We're going to finish up the rest of the questions in this review, and hopefully it'll help you on your EOC. So for 17, we got the value of a car exponentially or decreases according to the equation. Which part of the equation, so we're just looking for one part, represents the percent of decrease in the value of the car. So if we look at our equation here, y equals 33,400 times 1 minus 0.14 to the power of t. Our percent decrease is going to be that 0.14 is the part we're looking at, which is going to be 14%. All right, we need to graph the function. This is a quadratic function. We've got x squared and the value of a. Remember, this is ax squared plus bx plus c. So the value of a is positive, so we know our parabola is going to open up, and it's going to look something like this. We should need to figure out where that's going to be. So we want to find the vertex. So the vertex, remember, that's h and k. So h is negative b divided by 2a, which in this case is going to be negative 8 divided by 2 times 4. Getting those values from the a, b, and c up there. So that is negative 8 over 8, which is negative 1. So then to get k, we are going to substitute in negative 1 to the function. So that would be 4 times negative 1 squared plus 8 times negative 1 plus 8. And then let's figure this out. So we have 4 times negative 1 squared is 1. So we have 4 minus 8 plus 8. Those two 8s are going to cancel each other out. So we're left with just 4. So our vertex is going to be at the point negative 1, 4. So let's put in our lines here for the axes. Negative 1, 4 will be up here. And our y-intercept is going to be 8. So we know that c is the y-intercept, so that's going to be 8. So we're looking for the 8 on the y-axis, so 5, 6, 7. And then one more would be our y-intercept up here. And then we can reflect that point, because remember, these quadratics have an axis of symmetry. So that other point would be over here, and we'd have a skinny parabola that looks like this. So we need to be able to calculate the vertex, get the y-intercept on the EOC for sure. All right, solve the equation 7y plus 4x equals negative 3 for y. So we want y by itself, and that means we're going to move everything away from y. So I'm not going to touch y, but I need to move this negative 4x and this 7 to the other side of the equation. So let's see how we do that here. So I'm going to take away 4x from both sides. Normally they want this in like a y equals mx plus b. So we're going to put the negative 4x first. Then we have a minus 3. The only thing left we have to do now is divide by 7. And so I'll just divide everything by 7. So we'd have y equals negative 4/7 x minus 3/7. And then we could graph that if we wanted to, but that's going to be our answer. All right. Factor the following trinomial. We got a squared plus 15a plus 56. So remember, as long as the number in front of the squared variable is 1, then we can go ahead and factor this into a two binomials. And so the way we make a squared is with a times a. And then we need factors of 56, positive 56, that will add to 15. So 56 is going to factor into 8, 7, our two factors. And if we do 8 plus 7, that'll give us 15. So those are the ones that are going to work for us. A plus 8, a plus 7. If we were to distribute this back out, we would end up with what we started with. All right. Circle the equations that represent exponential decay. So remember, exponential decay is when the function is getting smaller. So the only way that functions get smaller, or that numbers really get smaller with multiplication, is when you're multiplying by something that's less than 1. So we want to look at the value that has the exponent and determine, are any of these numbers less than 1? So if we're looking at all of these, right, I'm just putting a box on all of them. Which of those are less than 1? Well, that's going to be where the numerator is smaller than the denominator. So that would be this function, the 2/3 is less than 1. So that's definitely one of them. 2/9 is less than 1. So we're going to take that one. 3/2 is bigger than 1. So not that one. And then we're going to take this one right here, 3/5. All right, so those are all going to represent exponential decay. Find the quotient, write your answer in simplest form. So whenever we have just one term in the denominator, we're going to divide each of these terms by that. So what I like to do here is do 4x to the 4th divided by 4x squared minus 8x to the 3rd divided by 4x squared minus 12x squared divided by 4x squared. I'm getting these minus from these negative signs up here. So 4 over 4 simplifies to 1. X to the 4th divided by x squared is going to be x squared. 8 divided by 4 is going to be 2. We're going to keep the minus. X to the 3rd over x squared is going to be just x. And then 12 divided by 4, keep the minus, is going to be 3. X squared simplifies with x squared. And this is going to be our answer after we do the division. All right. Does the data below represent categorical, numerical, and univariate or bivariate data? So we need to specify two things here. We're looking at these options and these options. Change the color there. So first of all, let's start with categorical and numerical. Numerical data is going to be obviously dealing with numbers. And so if we look at ages of students in the school, the ages of students in a school is going to be numerical because we're talking about what their ages actually are. We could take the average of their age to find the average age in our school. And so this would be numerical. Now we need to determine if this is univariate or bivariate. Remember, the difference here is one or two variables. So one or two variables. We're just talking about ages of students in the school. So this is going to be univariate. Only one thing we're looking at. If we're looking at ages and how they get to school, that would be different. Be two variables there. All right. So something like this would be bivariate data because we're looking at rock and roll, country, like what kind of music they like here. All right. So here we go. We need to fill out the two-way table. We know 50 of the teachers like country music. So that's country music. The teachers that like it, we're going to put 50 here. That's the total number of teachers that like country music. 20 of those teachers dislike rock and roll. So we're going to put 20 here for dislike rock and roll. So that would give us 30 that do like rock and roll. All right. 60 of the teachers dislike country music. So that would go here. 30 of those teachers like rock and roll. So that's going to be 30 there. And then we're going to have 30 here. And then we should be able to add all of those up. We got 60, 50. That's going to give us 110 total. All right, you deposit $200 into an investment account that earns 6.5% annual interest compounded annually. You make no additional deposits or withdrawals. What's the balance of this account after 5 years? All right, so we're going to use the compound interest formula. The amount equals the principal times 1 plus the rate divided by the number of times we compound, raised to the power of the number of times we compound times the amount of time. So in this example, our principal amount is going to be 200. And then we have 1 plus our rate is 6.5%. So that is 0.065. So 0.065 divided by the number of times we compound annually. That's 1 time per year. And then we're going to raise that to the same number for n, one time per year. And we have, or we're looking for 5 years, so times 5. So we are typing all of that into our calculator at this point. And remember, you do get a calculator on this test. So that's going to be $274 and 0.02 as the balance of our account. Graph the function, then state the domain and range. So first thing we need to know is what type of function this is. This is going to be absolute value. We know that because of the absolute value situation going on here with those vertical bars. So we know absolute value looks like a V, similar to a parabola, but it's got that sharp corner. And so we have 1/3 times the absolute value of x. So let's put our lines in here. So if you ever get stuck on a problem where you don't know, you could make a table and then just plug in those values. So typically you want to go around 0. So if we just did -1, 0, and 1, we'd get 1/3, we'd get 0, and we get 1/3. So we could do that. We know we have a point at 0, 0, 0, and then we would have a point at 1, 1/3, which would kind of be somewhere around here, and here would be our points. But we could, if we wanted to do something a little different, we could check some other numbers. Probably because of the 1/3, if we check -3 and 3, right, that would give us 1 and 1. So we could go out to here and get our graph. But a lot of the times on this test, if you do have to graph, you're going to be able to click any point that you know, and it should graph that for you. All right, describe the transformation from F to G. So we want to know what we're starting with and where we're going. So we're starting with F and we're going to G. So how did we get from -5 to 5? Well, it's a couple different ways, but 0 to 0 didn't really change. 7 to -7, 16 to -16. Looks like we're multiplying F by -1. So that would be a reflection over the, well, let's think about this here. So if the y values, if we had like, let's just look at that 0, 7. This was our, if the 7 was up here, and now it became -7, where did we reflect over? We reflected over the x-axis. All right, realize I forgot the domain and the range up here. So let's talk about domain and range. Domain, remember, that is dealing with the x values of this function. We're going to go forever to the right, forever to the left. So that's going to be all real numbers. But then we're talking about the range, and that is the y values in this graph. And nothing is below the x-axis. We're just going to be going up forever and ever. So that would be the y's are bigger than 0. That entire graph exists above the y being 0. Okay, complete the square. So we want to complete the square. Anytime we complete the square, we always want to make sure that we have 1 in front of the x squared. And so we take this 14, this middle term, the b value, and we take 14, we divide it by 2, and then we square it. So that's going to be 7 squared, which is 49. And so we're going to add that here. And because we added it on the left side, we're going to add it to the right side as well. And then we can go ahead and do, we'll have x squared minus 14x plus 49 plus 6 equals 0 plus 49. That's what that would look like. So then we're going to factor this part, because this now factors very nicely into a perfect square trinomial. X minus 7 squared. Basically, if we're trying to factor it, we just take the 14 divided by 2, and that number goes there. And whatever sign we have in front of that middle term, the b term, that's the sign that we get. And then we're going to have plus 6 equals 49. So now we want to solve for x. So I'm going to take away 6 from both sides. I still have x minus 7 squared. That's now equal to 43. And now I want to take the square root of both sides so that the square root and the square will cancel. Bring this up over here. So I now have x minus 7, because the squared went away, is equal to plus or minus the square root of 43. So then all I need to do is solve for x. So I'm going to add 7 to both sides, and I get 7 plus or minus the square root of 43. I can leave my answer like that, or if I needed to, I can put it into a calculator. I would do 7 plus the square root of 43 first, and then 7 minus the square root of 43, and that would get you 2 answers. Okay? All right. Your friend bought a used car for a total of 13,400. Total cost includes list price of the car, 7% sales tax on the list price, and additional 450 in fees. What was the list price of the car that your cousin bought? Okay. So we know we spent $13,400. And that's going to be equal to the list price of the car is X, and X had a 7% sales tax on the price. So we're going to have 1.07x plus an additional $450. And that's going to give us the cost of the car if we solve for x. So minus 450 minus 450, that's going to be 12,950 equals 1.07x. And we're here going to divide by 1.07. And that'll give us the price of the car. So X was $12,000, 102.80. That would be the list price of the car. All right, number 30. Friend's height for the first 10 years can be modeled by the function. What was the average rate of change? Remember, average rate of change means slope. So what's our slope formula? Y2 minus Y1 over X2 minus X1. So it says from year 4 to year 9. So that's your X1 and X2. So we're going to have, in our denominator, we're going to have 9 minus 4. But in the numerator, what are we going to have? Well, we need to figure out, essentially for this function, we want to know what is h of 4, or not 4, h of 9 minus h of 4. So what are the y values when t, in this case, is 9 and 4? So if we figure that out, then we're going to have our rate of change. So for h of 9, I'm just going to plug in 9 to that function. So negative 0.2 times 9 squared plus 6.9 times 9 plus 16. So let's figure that out. 61.9. So that's 61.9 minus, and then we're going to do the same thing with 4. Negative 0.2 times 4 squared plus 6.9 times 4 plus 16. Put that into our calculator, and we get 40.4. And that's going to be over 5, since 9 minus 4 is 5. So 61.9 minus 40.4 is 21.5 over 5, which is 4.3. So the average rate of change is going to be 4.3. All right. Which expressions are equivalent? So the same if we simplify as 8 to the 1/6 power. So let's see. Let's go through one by one here. So 64 to the 1/3, we can rewrite 64 as 8 squared to the 1/3, and then times 8 to the negative 1/2. So let's see, that's going to be, we multiply these exponents, so we have 8 to the 2/3 times 8 to the negative 1/2, and we're going to add those exponents. So we have 8 to the 2/3 plus negative 1/2. 2/3 plus negative 1/2, that's going to be, let's see, 4/6 plus negative 3/6, which is going to be 1/6. So we will get 8 to the 1/6, which is what we originally had. So this one's good. All right, 8 to the 2/3 times 8 to the negative 1/2. That one's going to be good because that's what we had down here. 8 times 8 to the 1/6, that is not going to work because we have to add 1 plus 1/6, and that is not going to be 1/6, so that's not good. The square root of 8 to the 6th, remember, if that's a square root, that is a 2 in the denominator of an exponent. So that's 8 to the 6 over 2, which is 8 to the 3rd, and that is not going to be it. But here we have the 6th root of 8 to the 1st, so that would end up being 8 to the 1/6 power. So we have those three options there. All right, equation of a line that passes through the points in the table. So equation of a line, we want to use y minus y1 equals the slope times x minus x1. You can get that from your reference sheet. So we need to know the slope and we need to know a point. So I'm just going to pick this point and I'm going to get the slope from looking at, remember, slope is the change in the y divided by the change in the x. So how is the x changing? Looks like we're increasing by 2. Over how is the x changing? Looks like we are increasing by 4. So that's 2 over 4, which is 1/2. And so I'll put that information in the equation. So I have y minus the y value I'm using is 1 equals my slope is 1/2. And then x minus the x value I was using is a 4. So that would be an equation of the line. If we needed that in slope-intercept form, we would distribute the 1/2. So that would be 1/2 x minus 2 and y minus 1. And then we would add 1 to both sides. And we would get y equals 1/2 x minus 1. So that would be the slope-intercept equation. All right. So they've started to like questions like number 33 because this is in the form of y minus y1 and then the slope in x minus x1. So we can actually graph this using point slope form if they give us that. So we have a point, so we can put that point, x1 is going to be -1 because the sign changed, right? It says +1. So we would have -1 and then 4 would be our point, and our slope is going to be -2. So -1, 1, 2, 3, 4. We have a point. Then we're going to go down to right 1, and we'd have another point there. And so our line would look something like this. But that would be for an equation. So what we want to do is we want to now make this a dashed line here because if we look at this, this is an inequality, right? So it says y minus 4 is less than -2 times x plus 1. And so if we moved the 4 over, we would have y is less than -2 x plus 1 and then plus 4. So as long as we have y is less than, that's going to be that's going to tell us where to shade. And so in this case, we're going to shade underneath. So everything underneath the graph gets shaded. So we shade below. We have a dashed line because we don't have the equal bar underneath the inequality. All right. What is the x value, or what is the value of the x squared term when 4x squared minus 3 plus 1.5x is multiplied by -2x minus 6? All right, so I'm going to use an area model for this. So I'm going to have 4x squared minus 3 plus 1.5x. And I'm going to have -2x, -6 here. All right, so I want to know the x squared term. So the reason why I'm using an area model is because this is going to be a little bit easier for me to see where my x squared terms are coming from, because I just need x squared. So I have a 4x squared here. When I multiply it by -6, I'm going to get -24x squared. If I multiply the 4x squared and the -2x, I'd get x to the 3rd. So I don't need that one. Um, Then, let's see, -3 times either of those is not going to give me, so I don't need those. 1.5x times -2 would give me an x squared. So 1.5 times -2 is going to be -3, and I'm going to have an x squared. And so those are my only two x squared terms. So I just need to combine those. So -24x squared minus 3x squared is going to give me -27x squared. So what's the value of the x squared term? Well, it's going to be -27. That's my answer. All right, you're on a paddleboard at the beach. Cost for the paddleboard is $30 plus $4 per hour. You can only rent the paddleboard for a maximum of 4 hours. Create a graph that represents the linear relationship between the price, which is y, so price, and number of hours is x. Okay, so here's our situation here. Let's see. We know that the cost is going to be $30 plus $4 per hour. So that would be our equation. Um, but we can only rent the paddleboard for a maximum of 4 hours. So if we were to mark off our number of hours, we know we'd have to stop there. So 10, 20, 30, 40, 50. Let's see if that's going to work. So what's the maximum number or maximum amount of money we could spend is if we did 4 hours. So that would be 30 plus 4 times 4, which is 30 plus 16. So $46 would be our maximum amount. So we have a point right around here. We know we start at 30, and so we could draw a line that connects those. So what would be an appropriate range? The range for this situation would be the y values would have to be in between uh, $30 and 46 because that's the amount of money we would spend. Okay. Height in feet of an object launched from a slingshot is represented by the function. X is the horizontal distance traveled by the object. Find and interpret the x and y intercepts. Okay. So x and y intercepts. The y-intercept is when x is 0. So we're just going to figure that out. -1/16 times 0 squared minus 55 times 0 minus 300. And we're going to solve that. That goes to 0, 0. So really we're doing -300 times 1/16, which is going to be 18.75. So let's see. So that would be the y-intercept, 18.75, and that would be feet, and that would be the starting point. Okay, so x-intercepts, we want to set y equal to 0. So we would have 0 equals -1/16 x squared minus 55x minus 300. And we're going to solve for x. So I'm going to multiply both sides by -1 or by, yeah, -16. And I'll get 0 equals x squared minus 55x minus 300. And I'm going to try to factor that. 300 would give me, I'm going to do 60 and 5, but I'm going to do -60 and +5 because that'll give me -55. So I'll have x minus 60 and x plus 5 is equal to 0. So that would mean x is equal to 60 and x is equal to -5. 60 is the only one that makes sense. So the x-intercept would be kind of where or how far it traveled before it hit the ground. All right, 37. Evaluate f of x equals 8x minus 4 when x is -3. This means to find f of -3. So we just replace x with -3. So that'd be -24 minus 4, which is -28. There we go. Solve x squared plus 8x equals -15. Whenever we solve quadratics and we have an x squared and an x term, we want them to be equal to 0. So x squared plus 8x plus 15 lets us set it equal to 0. And we're going to try to factor. That'll be x plus 5, x plus 3, because 15, we got 5 plus 3 gives us 8. 5 times 3 gives us 15. Set it equal to 0. X equals -5. X equals -3. All right. Solve the system. Whenever we have y equals, for both equations, that means we can set 4x minus 5 equal to -2x plus 1. That's just going to be substitution. So we'll add 2x to both sides. Gives us 6x minus 5 equals 1. Add 5 to both sides. We get 6x equals 6. Divide by 6. And we get x equals 1. Cool. All right, determine the value of the expression 2 square root of 24 divided by square root of 2. I'm gonna write it like this. 2 times the square root of 24 divided by the square root of 2, which means I can actually do this. When they both have the square root, I can put them both underneath 1. So that would give me 2 times the square root of 12. And so we would want to simplify the square root of 12. And we want to know our perfect squares. So that's going to be 4 times 3. Square root of 4 times square root of 3. And so the square root of 4 we know is 2. So 2 times 2 times the square root of 3. Our answer is 4 square root of 3. That's going to be evaluating or determining the value of the expression. Write an equation of a parabola that goes to the point 1, 8, has x-intercepts 2 and 3. All right, so if x equals 2 and x equals 3, that means we're going to write x minus 2 and x minus 3 as our equation. We're going to have a out front. We have y equals. So now they give you a point because 1, 8, 1 is going to be x, 8 is going to be y. So we would have 8 equals. We don't know a. We know x is 1. And then we have minus 2. And then we know 1. And then minus 3. So we're just going to solve for a. So we have 8 equals a times -1 times -2. So that's 8 equals 2a, essentially. Divide by 2. And we get 4 equals a. So we know a is 4. And so we're just going to put that where a is up here. And so our equation is 4 times x minus 2 times x minus 3. And that's going to be our equation of the parabola. Cool. So remember, you got multiple equations of parabolas. You got ax squared plus bx plus c. You got a x minus h squared plus k. You got a x minus p, x minus q. That's for your x-intercept. So depending on what they give you, you'd have to use one of those equations. All right. Equation of a line passes through -4, 7. So that's x1, y1, and is parallel to the line y equals 6x minus 2. So parallel, remember that means same slope. So the slope of that line is 6. So we're going to use that for our slope. So we have y minus y1, which is 7, equals the same slope times x minus -4, which is going to be plus 4. And so we'll put this into slope-intercept form. So y minus 7 equals 6x. That becomes a plus 24. We add 7 to both sides. So we get y equals 6x plus 31. And that's our equation. All right. Solve negative 3x plus 7 is less than 28 and graph the solution. So we solve this just like an equation. We subtract 7, negative 3x is less than 21, divide by negative 3. But be careful when we divide by negative 3, the inequality sign changes direction. So our answer is x is greater than negative 7. So we're putting this on a number line. We have negative 7 here. We're going to have a open point, and we are going to the right because we are greater than. Let me make that point a little different. There we go. Open point because it is not equal to. If we had the equal bar under there, then it would be closed. All right. Find the zeros of the function. So remember, zeros just mean x-intercepts. So we want to set y equal to 0. We have x squared plus 6x minus 16. And I'm going to factor that. Factors of 16 give me 8 and 2. I need positive 6. So negative 2 plus 8 gives me 6. So I'm going to have x minus 2, x plus 8. So x equals 2, and x equals negative 8. Hopefully we feel good about factoring. Okay. Function a of t models the speed of a car 2 minutes after it moves from a park position to a red light. What is the maximum speed the car reaches? Maximum speed is it comes from the vertex. So this graph is going to look something like this. And so the maximum speed is going to be at the top of that, right? So we need to get h, which is negative b over 2a. So in this case, that is negative 128 over 5 divided by 2 times negative 16 over 5. That gives me 4 in the calculator. And then I'm going to plug in 4. So I want a of 4. So negative 16 over 5 times 4 squared, which is 16, plus 128 over 5 times 4. So let's do that. And that gives me 51.2. And that's my maximum speed, 51.2. How long does it take for the car to come to a complete stop? So remember, that's going to be the x-intercept. So we're starting at 0. This graph, we start here, the car speeds up, and then it comes back to the x-intercept there. So if we take a look at negative 16 over 5x squared plus 128 over 5x, we set that equal to 0. We can multiply everything by 5 to get rid of the 5. So we got negative 16x squared plus 128x. And then we'll divide by 16. Negative 16, and that'll give us x squared minus 8x equals 0. If we divide everything by negative 16, and then to factor that, we could do factor out an x, and we get x minus 8 equals 0. So x would equal 0 here, and then x equals 8 is where it comes to a complete stop again. So 8 time is going to be, I guess, in miles per hour. So that would be 8 hours. All right, guys. Good luck on your EOC. Hopefully this was helpful, and I'll catch you in the next video.